We are on 5-6 today. This is inequalities in two triangles. In case you've forgotten, we've already covered inequalities in one triangle. If you remember, the smallest angle is across from the smallest side. The largest angle in one triangle is across from the largest side. We did that in one triangle. It's a pretty easy concept. So today there's two triangles, okay? So this is the Hinge Theorem. I'll draw a picture like you have in a second. If two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. Your picture makes a little more sense probably. So, you guys, oh, that's not a picture. Hold on. I hate when it does that. Try again. There we go. You guys have this picture. We've got A, B, C. Is that 85 at the top there? 85. This, that. Okay. And then X, Y, Z, bless you. Is that 40? Okay, thanks. All right, so remember a while ago when we were talking about side, side angle, that kind of stuff? So it's the same concept except for these two triangles aren't congruent, right? If they were congruent, then these two angles would be the same. So that's why this is an inequality, okay? So this is almost side angle side, except for the angles are different. Do you understand what I'm saying there? So if you're almost side angle side, and this angle is obviously bigger than this angle, then this side is bigger than this side. Okay, and that's what you guys have written down there. You have measure of angle B is greater than measure of angle Y, which is obvious, you can see it. So then that leads us to know that AC is bigger than XC. Do you guys get that? So it's not side angle side congruency because they're not congruent, but it's really, really close. Okay? And then we have the converse. We have exactly backwards. So this time it says if two sides of a triangle are congruent to two sides of another triangle, so same start to our picture, right? And the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first is larger than the included angle of the second. So you've got the same picture essentially, okay? I've got this, this, and then this side was what, 7 and the other one's 5? So I don't know what these angles are, but it's almost side angle side, right? If this side is bigger than that side, then this angle is bigger than this angle. Is that okay? Okay, I feel like it's not too terribly difficult to understand. All right, so we're going to compare the given measures. When they say compare, they're saying we know that we don't know how big they are, but we know that one's bigger than another one, right? So it's going to be less than, it's going to be greater than, something like that. So if you look at these two triangles, if it's one triangle, you don't have to think about it, right, like the other day. But if it's two, you have to make sure it's that Hinge theorem or the side angle side inequality theorem. It's the same thing, okay? So if you look, I've got an 8 and an 8. So I know those two sides are congruent. And I've got a 3 and a 3. I have to label it so that I know which angle I know. Do you see what I'm saying? So if I don't do that, I'm not sure if I'm talking about like angle L or angle P or what. So if you do side angle side, then what angle am I focused on here? L, right? If you do side angle side, S. They're not the same, but I'm going to go ahead and mark them so I know those are the two that I'm looking at, right? So if you look, they did go ahead and say MLP, which is the same as L, right? And TSR, which is the same as S. But I wanted to get there on our own, okay? So MP is 6, okay? And that's across from the L. So I'm going to put a 6 above it. Even though this isn't 6, it's across from 6. Does that make sense like we used to do it? Okay. And then angle S is across from 10. Which one is the alligator going to eat? That one, right? What's that symbol called? Less than. Very good. It looks like an L, so less than. Do you see how easy this is? You just have to be a little bit careful. Okay? So on this one, I've got two sides congruent. What are my other two sides that are congruent? The middle one, QS, right? QS is congruent to itself, right? So in the triangle on the left, QS is congruent to the triangle on the right, QS. Okay? So the angles I'm talking about are those two, right? So 38 is across from what side? The RS, right? So I'm going to put the 38 above that. That helps me. You don't have to do that. It just helps me kind of keep everything together. And then the PS is across from the 29, right? So what symbol do I want in the blank? The less than. Very good. Is that pretty easy, everybody okay? All right. So on your homework, when you do these, it'd be nice, even though they're going to have PS blank SR or like a question mark or something, go ahead and write the whole line. Don't just write the less than, because some people read it backwards and some people read it forward, so it'd be helpful to have the whole thing. Okay? All right, find the range of possible values for x. So this is kind of like what we did yesterday with the range, but it's a different concept. So we've got side angle side and side angle side again. Does everybody see that? So if you look, we've got the 57 is across from the 12, and the 41 is across from the 3x minus 6. What do I know about the 12 and the 3x minus 6? What, if I were to do, how did I do it? This. Say it again. The 12 side is bigger than the 3x minus 6 side. Does everybody get that from the picture before? Right? So before, we just had a 12 and like another number, but now we have an x, but it's the same concept, right? If the 12 is across from the bigger angle, then the 41 is across from the smaller angle, then the 12 side is bigger than the 3x minus 6 side, right? So what we're going to do is solve that. Solve for x, okay? So you would add the 6, get 18 greater than 3x, divide by the 3, 6 is greater than x. Most people don't like it that way, so if you put the x on the left side, the alligator was eating the 6 before, so it's still eating the 6. I didn't do any math from here to here. I just switched sides, symmetric property. Is that okay? Okay. So I think most people understand that, right? That was pretty straightforward. But if I say x is anything less than 6, anything at all, that doesn't make sense eventually, right? If I say x is like negative 100, because that's less than 6, right? If I put negative 100 in here, why is that a problem? Yeah, because this length would be negative, so that doesn't really make sense. Does that make sense to you? That doesn't make sense. So x is less than 6 is right, but we have to stop it somewhere. That's why they said find the range, okay? So it needs to be in between something and something. So what ended up giving us a problem here? Or what's the concept that we want to avoid? What do we not want? We don't want a negative length over here. So I need to say that 3x minus 6 can't be negative. How do I say that in math with an inequality? Can't be negative. So it has to be, yeah, it has to be positive, right? So to say positive, you would say, technically positive would be greater than or equal to 0, depending on the question, but we can't have a 0 side either. Do you see what I'm saying? So I want the 3x minus 6 to be bigger than 0. Does that make sense to you guys? So this part was easy. I think everybody got it. But because it said x is less than 6, eventually some numbers aren't going to work out. We're going to get a negative or a 0, and you can't have that for the length of a triangle. So I had to say, just kidding, make sure it's also greater than 0 as well. All right? We're not done yet. So we're going to solve this, and we're going to shove them together. Okay? So if I, what do I do here? Add the 6, good, and divide by 3, and you get 2. So what you do is you shove those two answers together. X has to be less than 6, but greater than 2, okay? So especially if you're in Algebra 2, this probably is pretty easy for you right now. If you're not, this might be a little bit hard. But it's like the range that we did the other day where you go smaller to larger, less, less, okay? So I'm going to do the 2, the 6, the x, less, less. That literally says x is between 2 and 6. Okay? If you look at it this way, x is less than 6, x is greater than 2, that's a range. Okay? If you kept them apart like this and you used like the word and, that would be technically okay, but this is the formal perfect answer. Is everybody okay? Did you understand what we just did? Okay. All right, last one, because we're not doing the proof. Same concept, right? So we start with the easy part, okay? So I'm going to say, is yours, did I fix this on here? Is this picture exactly like yours? Because my notes originally I had to change. This is right? Okay. So we're going to say what? The 2x plus 3, I'm going to start with that side. 2x plus 3 is what? 3x minus 5. Yeah. Does everybody get that? Obviously, you could have said it the other way. You could have said 3x minus 5 is less than 2x plus 3. It doesn't matter. That's just how I wrote it. Is that okay? So you guys solve for x really quickly. What do we get? Yeah, so originally you guys got this probably, and then most of you probably don't really like that, so you flipped them around. Is that okay? X is less than 8. Anybody need the math? Okay, so again, it said x is less than 8. If it had said x is greater than 8, I think it would have been okay, right? Because greater than 8 wouldn't have given me any problems. Less than 8 gave me problems, right? Because if I put in, again, negative 100,000, right, that's going to be a problem. So what do I have to say about the 3x minus 5 side? I have to say it's greater than 0. What about the 2x plus 3 side? I have to say it's greater than 0, right? I've got to do 2 this time, okay? So solve the 3x minus 5 greater than 0, and you just get x is greater than 5/3. That's okay. Leave it that way for right now, okay? If you make it a decimal, just don't round, right? And then on this one, x is greater than negative 3/2. I just leave it that way. You can write it any way you want, though. Is everybody okay with that? Your first answer is still part of your answer, okay? Typically, one of these is going to get crossed off. I'll show you how to tell which one in just a second. But your first answer is part of the answer, okay? And probably one of these is going to get crossed off. So obviously this one works in itself and this one works in itself. What I have to do is see if they work in the other one. Do you see what I'm saying? So like anything greater than 5/3 is going to work out in this problem because I just solved it to be that way. And then this one, anything greater than negative 3/2 is going to work in its own problem because I just said that. But now the question is, does this one work here and does that one work there? Do you see what I'm saying? That's how we're going to cross one of them off. Okay, so if I pick something greater than negative 3/2, so negative 3/2 is negative 1.5, right? Let's pick like negative 1, okay? If I put negative 1 in, let's see if it's still true up here, okay? What is 3 times negative 1? Negative 3 minus 5. Is that bigger than 0? So this one didn't work in both. Do you see what I'm saying? It worked in itself, but when I checked it in the other guy, it didn't work again. If you really wanted to, you could check this one as well. So that's what, 1 2/3. So if I pick something bigger than that, like 2, right? If I put 2 in here, is 4 plus 3 is 7 bigger than 0? Yeah, so that one worked in both. So our answer is these two shoved together. Do you see what we just did? Okay, so again, you usually go smaller to larger, you go less, less. So I'm going to say 5/3 less than x less than 8. The x has to be in between 5/3 and 8 to work. Bless you. Did I lose anybody? Does anybody have a question anywhere? We're not doing the proof? Okay, let's add a little note to the top because what we just did was only for sides and we didn't do any angles, right? So let's say the x is on an angle. You're going to do the same thing. It still has to be greater than 0 because angles in this class have to be positive. But what do they also have to be less than because they're in a triangle? 180. Yeah, 180, right? So at the top of your notes on the back, I added these couple little notes, okay? So you can put it wherever you want. I guess we skip the proof. If you want to put it there, you can. So the first thing I wrote was just to help us remember what to do when we had a segment. So I wrote the measure of any segment. If you want to put the word line segment instead, you can. But the measure of any segment is always greater than 0. So that's what I think you guys understood that. We said it greater than 0. I think you guys were fine there. That's like the examples we just did. But then angles, excuse me, are less than 180 and greater than 0 in a triangle. So you're going to have to set up 2. You're going to have to say that it's greater than 0 like we've been doing anyway, but you're going to have to set up another inequality and say that it's also less than 180 and shove those answers together when you get to an angle question on your homework. And if you don't understand what I'm saying, when you get there, just bring it over and I'll show you what to do. So you still do the first part like normal. Everybody was okay there. It's the second part where we have to say like a restriction that gets a little bit confusing. Okay? All right.